Let's take a look at solving growth and decay equations. We have this basic equation for growth and decay where, make sure I have the right pen size, where A is the amount that you have after T years, seconds, months. Here's our time. They're going to give you the unit in the problem, so it could be years, seconds, minutes, months. You got to read it to find that. K is the rate. Remember to convert that to a decimal. And E is just a number. And A naught is the starting amount, whatever it is that you're starting with. When we solve these kind of problems, talking and writing, when we solve these kind of problems, we've got 1, 2, 3, 4 variables. They're going to give us enough information to get 3 of those, and then we're going to solve for the other one. So we've got 4 different scenarios where just this one or this one or this one or this one is missing. And let's go through examples of each of those 4 and how you would solve those. Here they are with numbers in them as sample scenarios. The first one here is missing the amount that you have after 10 units of time given this decay rate and a starting population of 100. For the next one, the amount you have is 15, but we're missing the starting amount. We have the growth or decay rate here because it's negative in time. For the next one, what we're missing the time, but we have a growth rate, we have the amounts starting and what we have after T units of time. And for the last one, we have the rate missing, but everything else. Pause the video for a second and look at these and decide how can you solve these using your exponential equation skills. For the first one, welcome back. For the first one, we've got all numbers on the right sides. Just use your calculator, throw those in and find that. For the next one, the A naught is missing. If this here, this E to the negative raised to the negative 0.25 times 8, if that was just the number 17, you had 17 A naught, you would just divide by the 17. So do the exact same thing, because this guy is a number. So you would have A naught equals 15 divided by this. For the next one, we've got the variable stuck up in the exponent. So we have to get rid of this 15. It's multiplied, so we undo that with division. Divide both sides by 15 to get 25 over 15 and then reduce it. On the right, you still have this variable stuck in the exponent. We know to undo the exponent, we're going to have to go to logarithm, so convert to logarithmic form, and that will pop that variable right out for you. Actually, the last one you solve in the exact same way because the variable, sure, it's the rate instead of the time, but that's okay. It's still up in that exponent. You're going to use the same process for both of these. Now let's look at some specific examples. For this first one, we're looking for the amount we have after some amount of years. So the population of this city can be modeled by this function. T is the number of years since 1950. What was the population in 2000? So we're given the T. We do have to do a little translation though. Remember, it's the years since 1950. So we need to subtract and we get 50. So we get what is the population when T is 50. Substitute that in. 3890 times 1.037 to the 50. And now use your calculator because we have all numbers on the right-hand side. When you do that, you get about 23,926.95 with change. And we're going to round that to the nearest person using our rounding skills, 23,927. And that's how many people we have in Mathville in 2000. For the next one, we're looking for the starting amount. So we have the rate, we have number of, here it has years, and we have the amount we have after 5 years at this particular growth rate. So in words, the population of an endangered species has a growth rate of 0.025%. That percent should not be there. Sorry. Typo. Of 0.025, which is what's sitting here. If it was a percent, we'd have to have 2 more zeros leading in front of this. 5 years from now, they expect the population of that endangered species to be just 40. Here's the amount. How many are there now? The A naught is what you're looking for. Remember, this is what we're looking for. This guy's a number. Let's divide both sides by that. We get then A naught is equal to 40 divided by e raised to the 0.025 times 5, which is 0.125. So you get about 35. That's how many of that endangered species we currently have. Now we're looking for a decay rate, and there is no equation sitting here. Remember though, we use A, the amount we want, equals the starting amount times E raised to the rate times time. So let's see what pieces we have. We have T is 22, so we're going to put that in for the T. Find the rate of decay. That's what we're looking for, is that K. So they must be giving us A and A naught, and they are right here in the half-life of francium. The half-life is saying to you that we start with some unknown amount, but we will have half of that amount after 22 years. The K is what we're looking for. We can now just convert to logarithmic form. Natural log of 1/2 is equal to 22K. So K is equal to the natural log of 1/2 divided by 22. Grab your calculator. So K is about negative 0.031507 change, right? So the rate is about negative, I'll put another one so you can distinguish it from the negative sign, 3.15%. And we found the rate. Now remember, we had said earlier that when you're looking for the rate, you're going to use the same process to find the T. So I would like you to try to set this up and see if you can solve it. Pause the video, see if you can do it yourself, then come back and I'll walk through it for you. So how long does it take a meracium? So how long? We're looking for the T. It's in the exponent. To decay to 1/3 of its original amount. So 1/3 is equal to whatever we had originally times E raised to the, now it's 0.160%, so we need to convert to a decimal, 0.00160 times T. Convert to logarithmic. The log of 1/3 is equal to 0.00160 T. Solve for T. T is equal to the natural log of 1/3 all over 0.00160. So T is about equal to 686.6 change. So in about 687 years. And then you're done. Same process as the last one, right? So in general, here are the steps. You get the idea, I think. Take this equation, fill in everything you get. Remember, there's 1, 2, 3, 4 variables. E is a number on your calculator. So you're going to get 3 of these 4, and then you're going to solve for the one that's left. So you should have just one left. Use the techniques in the video to find that. Don't forget to put your answer in terms of the original problem, including units. Are they looking for a rate? Put it in a percentage. Are they looking for the time? Then what's the unit they're using? Put it in the units of time. That's it. Hope you're having a great day.